we're recording. Today's lab will be about define a class. So previously we've defined a function, now we'll define a class. We'll make some objects of that class. We'll sort of use constructors. We'll add properties after the object has been instantiated. We'll put things in, take things out, and so on, and do a little some stuff with regular expressions and some stuff with comma-separated variables files. That will be due then in a week. I think this will be the end of the material for test 1. So we'll finish it today. I'll give you a week to do it, and then we'll look to be having test, the first test sometime after next week. And so I will be asking when you have other major exams. I'll try to put it on days when you don't have other major exams. So not next week, but like the following week. Something to sort of know your schedule for that stage. Okay. All right. So what's due today is the JSON stuff. This was we read some JSON. We read JSON from the web. We added elements to a list. We added fields. And I also showed you some deleting. So you're supposed to read some JSON from the web. And they were posts from users. And you're supposed to get rid of all the posts from user 5. That's what's due today. Questions you want me to answer up here for the recording? No, he says no. Lab 6, which will be due Monday, is more complicated JSON. So it had lists within lists. So usually in JSON we have, if I'm using the JavaScript language, we have objects and arrays. And then this particular, I showed you a JSON of painters, which have paintings. So there were multiple painters, and each painter had paintings. And so that had arrays within arrays, or in Python language, lists within lists. And then the things also were dictionaries. And then I asked you to do something that was similar, in that the Nobel Prize site gave you JSON, which had an array of prizes. So different years and different categories. So there are prizes, plural, and then each prize, the prize can be shared by multiple laureates. So there was, again, a list within a list. And were there any questions? Not individual questions, but any sort of general up here questions on that before we start the new stuff? Okay. So let me start the new stuff then. So let's look at a class. So this has the class and the use of the class in one file. So here I'm using the keyword class to begin the definition of a class, and I called it hockey player. And this sort of predefined method called init __. So there are lots of things in Python that start with __, and this is one of them. So I'm defining the __init or initialize __. It has, there is eventually I will show you a way in which this comes up, but for now, just understand that like this is the way you do it. That the first argument is self. So usually that's in a number of other languages that is implied, but here we're putting it in explicitly. And then there are some occasions in which it arises, and I will show you at least one, but not today. Okay. So this just means when I make the object, this references that object. But when I call it, when I'm using the constructor, I haven't made it yet, so I will not be referring to it. So where am I using it? Here I'm using my hockey player. I'm using the name of the class, and the name of the class implies that I'm using its constructor. And I'm using here I have three things: an ID number and a first name and a last name. So that's the ID number, the first name and the last name. I'm not sending it self because there's no self to send it yet, but there are some weird scenarios in which that will pop up. But so that's one of the weird, newer Python-y things that you have. The first argument in the list is the reference of the object itself. But you don't have it when you call the constructor under normal circumstances, so you don't put anything there, but we will see it actually pop up. Yes.
So self would be, so ID first name, last name would be parameters, and self would be so the self would be how you call the constructor.
Self is like this.
Okay.
So self is, in other languages, this wouldn't, the self thing would not appear here, and you would be saying this ID equals ID, this first name. Okay. So another thing here is this parameter that comes in is just a local parameter to the constructor. And then this over here is a property of the object that you make of this class. They don't have to be named the same. This is the one that you will, this is just used internally to the function, like an argument of a function that, it is a method, the constructor is a method. So this is just a local name. And then these are the properties you will have access to in your class. And self is, you've seen it before, you've used it before, but you probably called it this. And you've probably not seen it, or maybe not seen it as an actual parameter in the constructor. So here is a definition of the full name. So this is a method in my class which constructs the full name. So there's this sort of, it's not always a dummy parameter, but I'm going to call it a dummy parameter, this sort of this self parameter. And then, but the other properties that I use to construct the full name are already known to the class. So I will say send back the first name and the last name separated by a space. So that's so I did not announce up here that I have any particular properties. I just, in the constructor, I started establishing properties. So I didn't have to put them here and then here again. It allowed me to just have them here. I have a method that constructs the first name. I have a method that constructs a URL. So I got this data from, this was hockey data, so I got it from the NHL.com site. They have pages made up for the players. And if you put their first name, you put this beginning URL, and then their first name in lowercase and a dash, and their last name in lowercase, and then their ID, then that will bring, that's the URL for a page about that player. So I'm constructing, so I have another method in my hockey player class that constructs that URL. So the usual idea of a class is you have some data and then you have some methods associated with that data. So I have the data ID, first name and last name. We're starting off simply, then we'll do more, and then some methods. Construct from the data a full name, construct from the data a URL. This is me instantiating a player. Nicholas, somebody, who happens to have this ID. And so that's the constructor. The constructor had self and then 3 things. When I'm using it in this capacity, I don't say anything about self. And here's the ID and the first name and the last name. I can add properties on the fly just by saying the name of the object, dot. If this is not a method or a property that already exists, it will make a new property. So it's going to add the property player num and give it a value of 62. So I'm going to print player num and see what it means to be an object. And I'm telling you here, it's just going to print out a memory location. Then I'm going to do __ dictionary. That's going to take the property parts of the player, forget about the methods, keep the property parts, express it as a dictionary, and so it's going to spit out some key value pairs. If I want a specific property I know of, I say last name. If I want to use a method, then methods have parentheses, the full name method. I'm not using the weird self thing, so the full name method is empty parentheses. I can access this property I made up on the fly, and I can use this URL property. Oh, this is a different way of invoking. So here is, this is where the selfie thing comes in. Okay, so I'm using the URL method. I'm taking the generic class hockey player, right? Not the class, not an object. I'm using its URL method, and then I want that for a particular object, and so I put in player 1. So I could say player1.url open close parenthesis. And then I'm using this without the, and the parentheses are empty. So the thing calling it is the object. But now I have the thing calling it is a class. And then, but I pass it the argument, which then becomes the self that we talked about. So that is, there are ways of calling methods where you send it the objects that you want. And it's just, sometimes that is easier than, sometimes if you're looping through a bunch of objects, this approach may be easier than to sort of get the object and throw it in and get a method from it. You can, if you're looping through a bunch of objects, you might just use sort of this method instead. But here I am using the class to use the URL for this particular object, and then I'm opening up that URL. So there is, so I imported that web browser class that I like to play with. And okay, so that was that. So we have some stuff down here. What did I print out? I printed out the player. which I said was a memory location. So this says it's a hockey player object, and here's its memory location. That's when I just printed the whole object. Then I said print the underscore dictionary. So here are the properties expressed as a dictionary. Then I said the last name as a property. So there's the last name. I used the full name method, which returned the string, which was the full name. And I have a player num property, and I established that after I instantiated. So I can add properties on the fly. Any questions? All right. So that was my first class. And I put the class and the sort of user or driver of the class in the same file. Now I'm going to separate them and maybe do something else, but all one thing is I'm separating them. Let me kill all the other stuff. Only something to look at. So now there's a class file. So this, oh, that's the use class. Here's the class file. I'm doing something with regular expressions. So this class is importing regular expressions because I'm going to have a method in there that uses regular expressions. So a class can have imports because the class is not just the dictionaries, not just the properties, but methods, and you may want to import things to use in your methods. Okay, so here's my hockey player class. Here's my constructor. Here's again that weird self thing we saw with that the last way I called it when calling it from the class. You saw where this self parameter can come in some of these methods. There was an ID, a first name, a last name. I've added a player num, and I've given it a default value. So the player num equals quote 00 here will, if I send it a player num 32, then it will assign that 32 to the player num. If I don't send it a player num, then it will put in this default value of 00, and then of course I can change it later. So if I know the player num, I'll use it. If I don't know the player num, I'll assign it later. But it will, before it just didn't have the player num, and then I assigned it on the fly. Now it's going to assign it in the constructor, but if I don't have the value, then it's going to assign the default value, which I can then later change. I still have a full name method, first name, last name. I still have the create the URL. I'm adding another method where I'm going to convert the height from a string. Now I don't have a height. I don't have a height parameter here. So I'm just defining a function. So I'm not going to, down in here, I'm not going to say what's your height self. I'm going to send it the height and then do something with it. So this, my hockey player may have almost certainly has a height, but it's not a property of my object or class. And so, but it made this function, this conversion may be something that I want that may be associated. So I may have some information that somebody's 5'11", and I may want to convert that height to all inches. So I want to make that functionality associated with my class, but I don't necessarily have this information in my class at any one time. So I have to send the information. So I'm making my other ones the full name, the URL, I didn't have to send data other than perhaps the object, because I was working with data from the object itself. This one, I'm working with data that is sent to me. So they send me some height as a string, then it's 511, 5 single quote, space 11 double quote. And now I want to convert that to a height in all inches. So they send me a height. I am doing a substitution, sub. In other languages, it's often called replace. I'm replacing, first I'm replacing any white space with nothing. And \s means white space, and plus means any amount of white space, not just a single white space, but if you see 2 spaces or anything, any amount of space, substituted with nothing. So basically we're getting rid of any white space. Then we're getting rid of the quote. This, what it comes in is 5 single quote, some white space, 11, and a double quote. This should be double quote. He's not 5 foot, 11 foot. He's 5 foot, 11 inches. Okay. So now I want to get rid of the inches. So I'm also doing a substitute here. But quote has a special role of defining the thing I want to replace. So I have to do a \/ quote. I have to do an escaped sequence quote. So I'm taking a quote, which I need a \/ in front of, and replacing it with nothing. So I got rid of the white space. I got rid of the quote. Now I'm splitting it. Now I have just 5 single quote 11. I'm not getting rid of the single quote. I'm using it as a delimiter. I'm splitting it up. And so I get my tokens, and my tokens are, I'm expecting 2 pieces, one for the height in feet and one for the height in inches. I'm converting the first token, the feet, I'm converting it to inches and multiplying it by 12. And then I'm taking the second part, the height, the inch part of the height, and converting it to integers and returning that. So if they said they were 5'11", then I'm returning, what is it, 71 inches or something. That's my class. Now I'm going to use the class in a separate file. So here's the file where I'm using the class. Well, if I want to use it, then I need to import it. So here is the name of the class, hockey_class_only, and I'm importing here the class. So I could have had a bunch of things over there, and this would only bring over the hockey player. That's the only thing that's over in the other class, over in the other file. But I can specify, if I have more things in the file, I can specify what I want to bring over. I'm bringing over the hockey player class. Here I'm making a hockey player with 4 arguments, 4 parameters, the ID, the first name, the last name, and I happen to know this person's number is 14. In this next time, I'm making the player, and I'm pretending I don't know his number, so I'm using the constructor, and this time it will pick up the default parameter for the player num, which is 0, 0, and then I can add in the player number. So we expect the first time for the player number to be 0, 0, and then for it to be 62. And then I'm going to use my new convert height from string. So I'm going to send it 5'11". I'm going to send it this person's height in that format I said I was expecting. And player 1 is an object of the class, so it has access to our function here. that function returns something, and that thing that's returned, I'm setting as a property of the object. And then I'm printing that answer, and then I'm printing the full dictionary. So where are we at? Here we at. So here's my first player, Sean, and I instantiated him, and that's the dictionary. The Nicholas, when I instantiated him, I didn't know a player number. It gave me the default value 00, then it assigned it a 62. I sent them for player 1, which I guess, who was that? Player 1 is Nick. I sent this height of 5'11", and it converted it to 71 inches and assigned it as a property of my object. Okay, questions? You're gonna have to do similar. You're doing, I have hockey players, you're gonna have basketball players. From the, I've got the data back in the spring, so if the 76ers fired anybody, there's lots of talk that they should, then my data is not up to date, and I don't care. You want to update it, you update it. Okay. All right, so that was version 2. I'm going to show you some regular expressions. Here, some regular expressions, some regular expressions. Okay. So I'm going to use sub, which is substitute or replace. I made up some test string, which has spaces, it has small letters, it has underscores, it has numbers, it has capital letters, it has symbols, more capital letters, more spaces, more numbers, more small letters, more spaces, just some long obnoxious thing. Okay. And I want to learn how to get rid of things that I don't want, or break it up into pieces. And so the first thing I'm going to do is get rid of any white space. I'm going to keep going back to the original. When you say substitute, if I take test and I substitute white space with quote, quote, in other words, if I get rid of the white space, it doesn't change test. It just changes it, a memory copy of it. And then if I want, and I'm going to make a new copy of it and call it test 1. But if I want this action to actually happen to test, I'd have to say test equals resub blah, blah, blah test. Then what I put down would actually happen to test. But I'm not going to ever do anything to test. So test keeps reappearing as the same long string from the beginning. Okay. So I'm getting in regular expressions, \s stands for white space. That could be spaces, that could be multiple spaces, that could be tabs. I think it involves new lines, all sorts of things are white space. So I'm going to get rid of the white space, call it test 1, and then I'm going to print it out. I'm going to put these vertical bars because I had some white space at the beginning and at the end. And you'll see it gets rid of the white space at the beginning and the end and in the middle. And I'm going to show you test and test 1s for comparison's sake. So down here is eliminate the white space. Here's the vertical bar around the original. Here's the vertical bar around the thing. And you can see there's no space. There's no space in the beginning, no space in the middle, no space at the end. Okay, so that was eliminating white space. Regular expressions have some, what \s stands for white space, \d stands for digits. So I can get rid of digits by doing a substitution of any digit it finds with quote, quote. So when I eliminate the numbers, you see the 1, 2, 3, the 7, the 8, 9, they're all gone. The spaces are back because I went back to the original test. So that is \d is numbers, and I can use it to get rid of numbers. Here's another way to do numbers. A square bracket represents a set of things. So if I say 0-9, that means the numbers in the range 0 to 9. And so I can substitute anything, any number between 0 and 9 with quote, quote. That's just a different way to get rid of digits. I could add here, if I wanted to do hexadecimal numbers, I could also add A to F. Okay, so this got rid of the numbers /D, this got rid of the numbers, my range 0 to 9. Here I'm getting rid of capital letters, capital A to capital Z. Down here, I'm getting rid of all letters, capital A to capital Z, little a to little z. That's all the things in that range. And then this last guy with the little caret in front is the opposite. If you're in square brackets, then a caret means effectively not. So anything that's not letters, I'm getting rid of. And so this is harder to see, but you can run it for yourself. Here I've eliminated the numbers. Here I've also eliminated the numbers. Here I got rid of the capital letters, which was the THE and the T. Here I got rid of all the letters. So it's the numbers and the spaces and the symbols. And here I got rid of everything I got rid of the stuff that wasn't the letters, or in other words, I kept all the letters, the ABC, the THs, the D, the whatever. So that is some games with regular expressions. I copied some data off of the internet for the 76ers. And they gave me like big long URLs for the player. Instead of saying, here's the player's ID, when I copied the data and put it into Excel to make a CSV, it copied the URL. And so when it copied the URL, I want you to grab out of there things like their ID or their name or what have you. And so I want you to be able to take this big, long, obnoxious URL and parse it and break it into the individual pieces we want. So that's why this is here. There's usually my examples lead you to what I'm asking you to do. And so I'm telling you in the Sixers file that I'm giving you, one of the things I give you is this big, long, obnoxious URL that you have to break into pieces. So you'll play some regular expression games. Questions? Okay, last one, more complicated. So I'm doing more with my hockey class now that I know more regular expressions. And I'm going to get the data now from a file. There is that. Hockey more complicated. Keep. Hockey more complicated. There's the class, there's the use of the class, here's the data file. Okay. So it has some ID. It has the name, it has this weird thing. So that's, I think, some kind of white space, but is not just simply a space. That's where the \s comes in handy. here is, I think that must be the player's number. This is, I don't know, stuff, position or right, what kind of hand they are, who the hell knows. Here's their height. So you know how to do their height. I guess that's their weight, their birthday. And then this gets complicated over here because it is, this data had commas in it. This was one field, but that one field had commas in it. So it gets weird with these quotes. So it's not, it didn't, so this was a one field originally, but now that field had commas in it. So now it's become sort of weird field, three fields in my comma separated variables file, but I have these weird quotes hanging on that you might probably need to get rid of. And sometimes there are two things and sometimes there are three things. So there's some weirdness in the place that they come from. Okay. So that is that file. What does the class look like? I'm using some regular expressions, otherwise I'm defining the class. Here's my constructor. Now I have all sorts of things in my constructor. The self thing, the ID, the first name, the last name, the player number, the position. These things I'm giving some default values to. So the player num, if I don't have it, it's 0, 0. The position, if I don't have it, it's underscore. The shot hand, I'm assuming there are more people right-handed. So if I don't know, I'm going to assume you're right-handed. I'm going to assume that you're 6 foot and 190 pounds. That's good weight and height for a hockey player, I guess. I'm going to assume that you were born on January 1 in 99 and somewhere in Canada. So I'm just making up default stuff for hockey players. Aren't they all from Canada or something? And then here is the data. Here's the first, here's constructing the full name, here's constructing the URL. We played that game before. I turned this convert height from string, I converted into a static method. So I can use this. Now, this time I want to use this to, before I make somebody. Before I used data, I had made somebody and I used the method, but I did not, so I didn't have the data to do the method, but I had the method because I had the object. That was a long, complicated rattling. Anybody wants me to repeat it? I'll repeat it. I want me to repeat it. The last time when I used that method, I had made an object before I used the method. This time I want access to my method even before I make the object. Because I want to get their data, I want to figure out their height in inches, and that's what I want to be in my object, is their height in inches. So I want access to this function before, that belongs to the class, before I've made an object of the class, and therefore it's a static method. Yes, we've heard this before. No, we haven't heard this before. Java people should know this. Maybe people who only had 230, maybe not. But if you have a class, if your class has a method and you want to be able to use the method without making an object of the class, then you want a static method. Okay. So this is a static method. I don't have to have an object to be able to use it. And then it's what we did before. We got rid of the white space. We got rid of the quote. We split it on the single quote. And then we did our calculation after we cast them as integers. I added another method to calculate the BMI, body mass index or something like that, which is the some number times the weight divided by the height squared. In Python, you can get squaring by doing asterisk, asterisk. So asterisk, asterisk 2 is squaring. so that is now my class. I added more properties with more default values. We always had full name, we always had URL. We turned this into a static method, so I don't need an object to use it, and I added a BMI method. Okay. So now let's use it. I'm going to do some regular expressions in this file as well. I'm going to do my usual operating system thing to make sure my terminal is located in the right place. I am bringing in the hockey player class. Okay, so those are my imports. I'm going to make a list of hockey player objects. So I'm making a list. I'm opening the file. There is a CSV class that you can import. I think CSVs are easy enough, then I just tend to do them myself. But there is a CSV class, and if you want to look up how to use it and you use it, that's fine. My CSV has headers at the top. And basically, I'm here just saying, read that one line of headers and leave, I'm not doing anything with them. I just need to ignore it and not try to make a hockey player out of that. And then I start looping through the lines and I get rid of some white space and I get rid of spaces on the end and I split it based on a comma. And I'm taking the second thing. Here's the second thing is there's an ID, and then the second thing they have here some kind of a name, first name, something, and a last name. I'm splitting it on white space. So this is that. This is after I split it on a comma, this is the second thing. So this is the name, and I'm splitting it. So I'm making it into, and making it into parts. So part 0 will be the first name, parts 1 will be the second name. This 1 means only split it once. So there was somebody there with one of those van names, James Van Riemsdyk. And I didn't want to split it into 3 things. And that's what that 1 is doing for me there. It says only split it once on the first occurrence. Okay, so that was fun. So now I'm making my flyer object, or making an element of my flyers list, which happens to be an object. So I'm using my hockey player in constructor. Here's the ID. Parts is the first name. Parts 1 is the second name. X2 was whatever X2 was supposed to be. What comes after? The player number. So that should be the player number. Then 3, 4. Position and shot hand. Then we're coming up to the height in inches. So now we have to play more games. They have the height as 5 / 11 double quote. And so I'm using my static method to convert it to the format I want. 6. So that was the weight I want to convert into an integer. So I'm casting it as an integer. And 7 and 8, what were 7 and 8? The birth date and the place. The place is going to be screwed up, and I'm not going to do anything with the place, so don't worry about it. Okay. Here's me looping through all the players in my list and showing you their player number and the player's name and the BMI. And then I'm asking the user of the terminal to enter a player number. And then I'm going to get the player with that number. So I'm finding the next, here's how I can go from, I have a list of objects and I can get the next one. So for the player in Flyers, if the player number is equal to what the user entered, that's how I can grab the one that they, so I can make my own loop and loop through all of my players and say, is your player number this, is your player number this, is your player number this, but they have a built-in method for that called next. So they sort of built in that structure. It's a thing that occurs often enough, so they do it. If I have a user with that number, then I'm going to open a web browser and open it up to their URL. And if that fails, then I'm going to say maybe that wasn't a good player number. Let's see. So that out of the way. So here's all the BMIs of all these guys, all nice in the mid-20s, so they're nice, healthy. Football players get up into the 30s because they're super big. Who do you want to look at? Justin Braun, who the hell that is, I don't know. 61, and oh, that's Justin Braun, okay. So any questions on that? You're going, so that was hockey players with the hockey player data. Now you're going to do basketball players with the Sixers data. So let's see what you have to do. All right, so that's where I took the information from back in the spring. I put it into a CSV. You're going to make a class with a bunch of properties. You're going to have methods that takes height into meters and weight into kilograms. So I'm asking for some different classes. And the URL is a slightly different URL because it's a different site. Now this is an ESPN site. And so you're going to make what, make the class, read the file, loop through the file to make the Sixers object, print out the name and the age and the salary, and then open a browser. What does the data look like? It's this long URL. I want this number out of it. So I didn't ask for this URL. I asked for this ID number to be part of my class. So you have to do a little bit of regular expression, pulling stuff out to grab that number. Then the first name, now you have the name, Sept space Curry 31. So somehow when I grab this data off of the internet, the number got put in with the name without a separator. So you've got to get the first name separated from the last name separated from the number, because that's the way the data came. I cleaned up the salaries for you because they had extra commas in them. But I didn't clean this up. That's your job. And you don't clean it up by going into the CSV and typing it. You're supposed to handle it on the fly in code with regular expressions. The weights have these pounds hanging on. You probably want to get rid of those pounds. So do you know what to do? Any questions while we're recording?